All right, this is 2.1a, slope of a tangent line. So let's bust out our graphing calculator, and we're going to graph these four functions and talk about tangent lines in it. So I have this zoomed in at 0, -5, and so our curve, this cubic, is the blue. All right, and so is the red line, this x minus 5 is the red line, is that tangent to the curve right there? Does it only touch once? Does that red line do that? No, it looks like it crosses to me. How about the black line? This black line is 2x minus 5. Does it just touch right at that curve? No. How about the purple line? Does the purple line look like it just touches right at that curve? Yes. And so that's the capabilities that we're going to be talking about today, is what it is to be a tangent line. So back in your other math classes in geometry, you had to do tangent lines of a circle. And so they touched once on that circle. And there was a cool little thing about it always being perpendicular to its radii. And so that's what tangent line was. Now, what is the slope of the tangent line on this like quadratic type thing? What's the slope here? 0. And that's going to come up in a lot in our math classes. All right. And so when a tangent line is 0, it's quite special. This is a tangent line, but it kind of cuts through a little bit, but it's only touching one time. And this is actually something else that we talked about a little bit yesterday, because this looks like it's concave down and this looks like it's concave up. So what really is happening right here? It's a point of inflection. We talked about that last year. This is also a tangent line at this point, even though it does cross at this spot over here. Okay? And so those are our different types of tangent lines. And so we're going to be kind of talking about those tangent lines. We're going to be talking about these secant lines. And a secant line touches how many times? Twice. And so this is our equation of our secant slope. We looked at this equation before, and we're just going to add one little thing to it today because we finally finished chapter 1. And so really to find a slope of anything, we just do y2 minus y1 over x2 minus x1. Yes? Okay, which is algebra slope, exactly. And so we go out a certain value of x. That's what our delta x, that's our change in x. And so to find the y value of it is we have f of c plus delta x. And then minus our original y value of f of c, and then it'd be the x2 minus x1. So it's this c plus delta x minus c. And beautiful things happen. Guess what happens to the c's in the denominator? They cancel. And so I'm left with this portion. So before we're actually going to be talking about is we're going to have secant lines approaching a tangent line. And what happens is we get closer and closer to our point of tangency. So instead of having a secant line, we start having a what? A tangent line. When we get close and close to 0 for my delta x. That delta x actually approaches 0. So the equation of our tangent line, or the slope of our tangent line, I should say, is our limit as delta x approaches 0 of f of c plus delta x minus f of c all over delta x. And that is what our slope of our tangent line is. So we got this function 2x minus 3, and I'm going to find the slope of that function using this definition right here. Okay? And so all we're going to do is utilize that little definition. So we're going to substitute in c plus delta x in there, and then we're going to substitute in c. All right? So we're going to have a limit as delta x approaches 0 of 2 times, what do we substitute in first? C plus delta x minus 3, and then minus the quantity. Now I need to do f of c. So now we're going to substitute in what? C. So now I have 2c minus 3 all over delta x. Now we're going to distribute this 2. So we have to start simplifying. So we're going to distribute this 2. So now what do we get? 2c plus 2 delta x. Then I still have minus 3. Now what do we do with this little negative thing? Pew, pew. Good. All right, so now we have minus 2c and then plus 3. All over delta x. As my limit as delta x approaches 0. Now, lovely things are going to start happening. What lovely things happen? My delta x's do not cancel yet. They will, but not yet. My 2c's cancel. You have to do it in order, though. You really do. All right. Then what cancels? My 3's cancel. Then what can cancel? Now delta x's can cancel. So now I have a limit as delta x approaches 0 of what? Just 2. And so what is my limit as delta x approaches 0 of 2? It's just 2. And so the slope everywhere on this curve is what? The slope is 2. Now, why did we know that? Okay, so it's at the point 2, 1 as well. So the slope is 2 at 2, 1. All right, but the slope is actually going to be 2 everywhere because this is a what?
Oh, it's
a linear. Okay, we knew that. However, I wanted to prove to you using this definition of a tangent line slope. All right, but it should always be 2 because it was linear. All right, function x squared plus 1. So now our function is x squared plus 1, and we're going to utilize it finding the slopes at 0 and at -1. And we'll probably do more than that too. But again, we're just going to substitute in c plus delta x and substitute in c, find its difference, and all that good stuff. All right, so let's set it up. So now I have a limit as delta x approaches 0 of, what do I substitute in first for my variable? C plus delta x quantity squared. And then I still have plus 1. All right, so that was this f of c plus delta x. Now, minus, now what do I substitute in? Just what? Just c. So now I have what? C squared plus 1. And then it's all over delta x. So now we have c plus delta x, and now I need to square it. So this is my favorite 4-letter F word. What is that? Foil. Very good. And so we're going to foil it. So what's my first? C squared. Plus, what is my outers and inners combined to? 2c delta x. And then plus what? Delta x quantity squared. I want to go off to a side note real quick. Delta x squared is not equivalent to the quantity of delta x squared. Okay? So this is incorrect. This is correct. Okay? Because this actually means the change of x squared. This means the change of x quantity squared. Okay? So anyway. All right. So then I still have plus 1. And then what do I want to do with that little negative? Distribute it. So now I have minus c squared and then minus 1 all over delta x as my limit as delta x approaches 0. All right. Now lovely things are going to start happening. What lovely things happened? C squared's canceled. What else happened? My 1's canceled. All right. Now what can we do? We can distribute dividing from delta x. So we're going to distribute dividing delta x. So that one's going to go bye-bye. And then this one has a degree of what now? 1. All right. And so now I have a limit as delta x approaches 0 of what? 2c plus delta x. So that is my simpler function. And so now when I substitute in 0, what do we get? We get 2c. All right. And so now I can finally answer our question. So at the point 0, 1, so my slope at 0, 1 is what?
2c.
Okay, so now I'm going to just substitute in 0. And so what do I get?
0.
I get 0. So my slope at 0, 1 is 0. And now I can find my slope at -1, 2. So now I substitute in my input value. And so what would be my slope at -1? -2. And I want to show you how powerful that really is. This is a quadratic. The quadratic is x squared plus 1, so it should look like this, yes?
Okay, yes, parabola.
Okay, it's a parabola. Beautiful. All right. And so what we did is we found the slope at -1 would be what? Oh, why did I say -2? This is -2, silly goose. All right. And so the slope at -1 is what? -2. Slope at -1 is what? -2. So then what's my slope at 4? What's my slope at x equals 4? It would be 8. All right? Because I just substituted in there. I can find my slope at any given x value of that entire parabola. So my slope at 4 would be super slopey of 8 over there. All right? Which is pretty powerful. All right, so now we're going to find the slope of 3x squared plus 4x. We're going to test our algebra skills. All right? So again, all we're going to do is substitute in c plus delta x minus f of c all over delta x as my limit as delta x approaches 0. All right? So here we go. So now I have a limit as delta x approaches 0 of 3 times, what do we substitute in first? C plus delta x quantity squared plus 4 times c plus delta x. Then what? So that's the f of c plus delta x. And then what? Minus f of c. So now what would my f of c be? 3c squared and then plus 4c. All over what? Delta x. We got a FOIL. Let's FOIL. So when we FOIL, I still have a 3 chilling. And so what does the c plus delta x quantity squared go to? C squared plus 2c delta x and then plus
Delta x quantity squared.
there it is. And then plus, what are we going to do with that 4? Distribute it. So now we'd have what?
Plus 4c.
Plus 4 delta x. And then what do we do with that negative sign? Distribute. So now we have
Minus 3c squared.
3c squared minus 4c all over delta x. All right. I would do one more step before we start canceling out. What should we do with that 3? Distribute it. So now I have what? 3c squared plus 6c delta x plus,
3 delta x squared. Quantity of delta
good,
x squared.
and then plus 4c plus 4 delta x minus 3c squared minus 4c all over delta x as my limit as delta x approaches 0. All right, lovely things are about to happen. What lovely things are going to happen?
3c squared cancels.
The 3c squareds cancel.
4c cancels.
And the 4c's cancel. I want to kind of stop right there for a sec. Every single time you do these problems, once you substitute in c, that thing's going to cancel. Your f of c is going to cancel every single time. And if they don't cancel, you did it wrong. Okay? Every single time it will happen. All right? So now what happens? Now what do we need to start doing? Distribute dividing. So everything's going to lose a power of 1 for my delta x. So this is going to now have that cancel. This delta x squared will be a power of 1, and then that delta x goes bye-bye. And so now I have my simpler function. Bless you. So now I have a limit as delta x approaches 0 of what? 6c plus 3 delta x and then plus 4. So now we substitute in 0 for what? Delta x. And so now what do we end up with? 6c plus 4. All right. And so if I were to find a slope at x equals 1, guess what it would be? It would be 10. If I had to find a slope at x equals 0, what would it be? 4. And so now I can find a slope of any x value of that quadratic with this formula. All right? And that is so powerful if you really think about it. All right? And so that's what we did today. All right, let's practice these slopes. And here we